everyone. So today's video is about series circuits and parallel circuits. Last video was about EMF and internal resistance. So when I made that video, I just realized that a lot of people may not be 100% aware of how series circuits work, how parallel circuits work, what happens with the resistances, what happens with the voltage or potential difference, what happens with current. So this video is about series circuits, parallel circuits, how we deal with voltage, current, and resistance in that. So let's just hop into that. Okay. So I would not go into a lot of detail that is unnecessary. So at the end of the day, you just need to understand what it is as much as you need and be able to solve any problems that come in the exam. So I'm just gonna I'm just gonna go through that stuff. So first we have series circuit, right? So series circuit. So a few things that you should know. What is for first of all series circuit? So series circuit is basically when the load or resistance. It can be a load, it can be a resistance. So let me just make a let me just make up a circuit. So I'll just connect a resistance there. I'll connect another resistor there. And instead of adding another resistor, I'll just add a lamp. I think it is denoted by a symbol like this. So at the end of the day, it is the same thing. Okay. So this is a load, but it is also a resistor because every load is a resistor basically. The only difference is when you say that it is a resistor here, it is just a resistor. It's not doing anything for us other than just creating some resistance in the flow of current. But essentially it does the same thing to current or to the potential difference. So yeah, this is like a circuit. What I'll do next is I will also, yeah, the eraser does not work very good, but I'll just also add an ammeter. You should always know that an ammeter is connected in series as well. So a series circuit is when everything is connected in a single chain, in a single line. So when current passes, it passes, the same thing passes through all of them, and it's like a closed loop. So we say that this is basically a series circuit. So I'll connect an ammeter. Remember, ammeter is always connected in series, and potential difference is always connected in parallel. So uh, if I connect a potential difference across just this, I connect a voltmeter across just this resistor, I'll connect it like that. If I connect another voltmeter, I'll connect it in parallel with this resistor. And if I connect another voltmeter, I'll connect it like that across this lamp. So yeah, that is the first thing to know what is a series circuit. So a series circuit is when all of the components, for example, resistors or a lamp or any other load is connected in a single line, in a single path. Then we say that it's a series circuit. Okay, what are the other rules about series circuit? So the first one is that the same current passes through everything. So if you connect an ammeter here, or if you connect an ammeter, let's say if you had connected it here, it would give you the same current everywhere. So the same current passes through each and everything. I'm just trying to look for an undo button. I'm not sure where it is, but okay. Never mind. I think I found it. So yeah. So wherever you connect an ammeter, it will give you the same reading in a series circuit. Because if you think about it, what is current? Current is basically the flow of charge, and charge is something physical, right? So if charge starts to move from the positive terminal of the cell or a battery, it and obviously this is the only path that it can go through. So obviously that charge will flow through each and everything, right? It will keep on flowing like this. It will keep on flowing like this until it gets back to the negative terminal of the battery. So that means the same charge flows through everything, which means that everything should, every point in the circuit should have the same current flowing through it, right? So let's say the current that passes through this resistor is I1, The current passes the total the current that actually passes through this resistor is I2. The current that passes through this lamp is I3, and the overall current or the total current we call it IT. So according to that, the total current IT, you can also just call it I, is actually equal to I1, which is also equal to I2, which is also equal to I3. Why? Because current is the flow of charge and the same charge flows through everything. So the current remains the same throughout the circuit. So that's the first rule about series circuit that you should know. The second rule that you should know is that the potential difference across each thing is different. So the voltmeter reading that you get from here, let's say it's V1. The voltmeter reading that you get from here is V2. The voltmeter reading that you get from here is V3. And the total potential difference of voltage that is provided by the battery is the rated potential difference is V. You can also measure that if you connect a voltmeter like this across the uh, across the battery as well. So as per that, the total, because what is potential difference? If you remember, it is the work done per unit charge, right? So basically, every component in the circuit would require different work to be done on them for the current to flow through them. So whatever is the total potential difference, let's say it's called VT or it's just called V, it would be equal to V1 plus V2 plus V3 because the potential difference actually splits in the series circuit, if that makes sense. So these are the two rules that you should know. And the next one is what is the total resistance of the circuit. So the total resistance of the circuit is, I don't think you need to derive this. You can always derive it using this formula, and V is equal to IR. You can use these two to derive easily the total resistance of the circuit, but eventually the formula would be that the total resistance obviously is, if you see, the current would face first this resistor, then this one, then the lamp. So everything will try to stop the current to flow through it. So the total resistance, if you call it RT or if you call it R, would be actually equal to R1, the resistance that is in the for the first resistor, plus R2, the resistance of the second resistor, plus R3, which is the resistance due to this lamp as well. So because every load has some resistance as well. So these are the three formulas. If you know these three formulas, you can solve any question related to series circuit. So it's that easy. All right. Now okay, I will move to parallel circuits now. So what are parallel circuits? So parallel circuits are when the loads are actually connected in parallel to each other, which means that they have different channels for the charge to flow through them. So for example, let me make the battery correct this time. That was a cell that you saw earlier, just for your information. So for the battery, you make a sign like this. So basically, a parallel circuit would have loads or resistors connected in parallel, which means they are split up into different pathways for the charge to flow through. So I can have as many as I want. So they would be connected like this. Let's say this is R1, this is R2, and this is R3. So I can choose a lamp here as well, does not matter. All of them would provide some resistance. So I've just made resistance for all of them. So yeah, so I can maybe add a ammeter here, and maybe I can add an ammeter here as well, and here as well, and here as well. I can add voltmeters here as well, because they should be connected in parallel to the uh, thing across which we want to measure the voltage. So it's like this. So the first thing, obviously, if you think about current now, the current does not have only one path to go through. It has to split in all of these three paths. So it starts from here, Now it has two ways to go. It can go down from here, or it can move through this path as well. Similarly, here it has another option to go here or downward through the other resistor. So, if you think about it, now all the charge cannot go through the same path, right? So the total current that is being provided by the battery, you can write it as IT or you can write it as I, is actually equal to I1, which is the current flowing through the resistor 1, plus I2, the current through resistor 2, plus I3, because the charge actually splits up. So that is the difference, first difference between series and parallel circuits. Now, the second difference is the voltage. So, okay, the voltage remains the same in these circuits, in the parallel circuit. So this voltmeter will give you the same reading as this voltmeter. It will give you the same reading as this voltmeter. And if you connect another voltmeter here, it will give you the same reading. So basically, Vt is equal to V1 is equal to V2 is equal to V3. Does that make sense? So the voltage was split in the series circuit because it's split through different resistances. But now since these resistors are in different pathways in different channels, so the voltage or the potential difference, it does not does not change. It every each one of them, if you think about it, in the series circuit, first the current would need to pass through this resistor, then the current would need to pass through this resistance, then the current would need to pass through the lamp. So eventually, some of the load was taken by some of the potential difference from the chunk that the battery can provide was taken by this resistor. Then some of that was taken by this resistor, and then through the whatever was left was taken by the lamp. In the case of parallel circuits, now each one of them have their own paths. So whatever goes through this, whatever charge goes through R1 does not need to go through anything else. Whatever goes through R2 does not need to go through anything else. Whatever goes through R3 similarly would not need to go through anything else. So in that case, the potential difference across all of these would be the same, and that would be the uh, total provided by the battery. So if you think about it, uh, like if you have something that runs on 6 volts, right, and you have two batteries that are 3 volts each. So if you have to, so basically, if you have to run something that is 6 volts, what you need to do is you would need to connect both of them in series so that whatever thing which is rated to run at 6 volt actually gets 6 volts out of it, right? So this is kind of a load which is rated to be operated on 6 volts. So you would need to connect both of the batteries together, because uh, potential difference, it just adds up. As I told you, if anything is connected in series, at the end you add the potential difference. So you would need to connect it like that. If it says that it's 3 volts that is needed to run something, you would connect those two cells or batteries in parallel, so that because they are connected in parallel, everything would get 3 volts. So they won't add up like that because it's something like this. So yeah, that is that. And because we don't need to derive it, it's just for you to remember. And if you remember these formulas, you can solve any question. So we won't go into detail of how to derive them, because I don't think you need that to solve any question in the exam. The third thing is about resistance. So we have talked about current, we have talked about the potential difference, what happens to it in the parallel circuit. The third thing is the resistance, and you can prove it, and I can prove for you, but I don't think you need it. So I'm just going to write the formula for you. So 1 over R, which is the R is the total resistance of the circuit, or you can also write it as uh, 1 over RT is actually equal to uh, 1 over R1 plus 1 over R2 plus 1 over R3. So this is how you, if you know other resistances, you can, or if you know all of the resistances, you can calculate a total resistance. And there is a very famous statement, uh, which you don't need to remember again, because if you know the formula, you don't need to do that. But just so that you have it in your mind when a question like that comes, and you don't need to go through rigorous calculations or anything, you should know that the total resistance of a parallel circuit is less than the lowest resistor resistance of the circuit. What does that mean? So, for example, if you have something like this, let's say you have a battery connected to a few resistors. So the above statement, okay, before going through that, let's say that this is, let's say that this is 3 ohm, this is 5 ohm, this is 7 ohm. So what do you know for sure before even solving it? And according to this statement, is that the total resistance of the circuit, let's say it's RT, would be less than 3 ohm, because the statement says the total resistance of a parallel circuit is less than the lowest or the least resistance of the circuit. So the least resistance here is 3 ohms. So this channel has the least resistance. The total resistance would come out to be less than that. You can always prove this when you put the values in this. You can always prove that. So it's just that you don't need to remember it, but sometimes just to save some time in exam, if you know, if you remember this and you see some multiple choice questions, you can always know that whichever option is shows that uh, maybe you have four options, and the lowest option, there's only one option that is lowest than the least resistance in the circuit. So you don't need to do any calculation, just take that and it should be all right. So I believe that yeah, so I believe that this is everything that you need to know about series and parallel circuits. If you remember these formulas, you can basically solve any question around series or parallel circuits. And if you understand this, you would easily understand everything we talked about, the EMF and internal resistance topic. So I hope you liked the video, and I'll keep sharing more videos as well. So thank you for watching.